sky's the limit, and I'd like to introduce you all to Brooke. In competitive sports, there is a big problem with high susceptibility to heat-related injuries. It's because athletes and workers are pushing themselves far too hard in the hot environments. Workers, especially workers in hot environments, they may say like firefighters or military members have to work very long hours in a lot of protective gear. And these injuries are preventable. Part of the problem is we're reliant on people's perception of how hot they are. So it's highly subjective. Somebody may feel, oh, maybe I feel a little dizzy, I'm just being weak, I'm just going to keep pushing until eventually they drop. There is a limited number, especially in athletics. There's a limited number of individuals to monitor athletes and workers in these hot environments. So we needed technology that would allow simultaneous monitoring of large number of athletes and workers by even a single individual. We can monitor temperature and heart rate and objectively assess the danger of a heat-related injury because of course this is caused by the body's getting too hot.
The hardware we have on this project is a TNC 3.0 microcontroller, a Arduino LilyPad temperature sensor, the pulse sensor and optical heart rate sensor, Bluetooth Mate gold modem, nickel metal hydride battery using compression garment, and a laptop. The Bro is a device with a heart rate monitor and skin temperature sensor integrated into a sports garment. It is going to read the data from those sensors and transmit over Bluetooth to the laptop. It's going to constantly monitor temperature and heart rate, transmit that information, and allow remote monitoring of many individuals at the same time. How does it work? Our temperature sensor is a thermistor type. It will measure the temperature of wherever it's at on the body. It is meant to be sewed into a garment, and it will output a voltage. The optical heart rate sensor, it measures. It's got an LED light on it, which and it measures how much of that LED light goes through the skin to the other side to measure the amount of light flow through the capillaries, and that's how it determines the volume changes, what is pumped. Those both are connected to the TNC microcontroller, which converts the voltage signal from the thermistor temperature sensor to analog. And all those are, the TNC is powered by nickel metal hydride batteries and provides the voltage for the sensors and the Bluetooth module, and sends the data through the Bluetooth module to the laptop. Alright, like I said, the heart rate and temperature sensors send data to the TNC, and the data is sent via Bluetooth to the laptop. The temperature is then graphed by MATLAB with the heart rate on a graph, and there's a box in the middle of the graph that displays the heart rate. And then the data that is displayed on MATLAB is captioned and stored in a MATLAB file. This is a representation of how it works. It takes in the skin temperature and the pulse from the optical sensor, and those sensors read those, sends it to the Arduino board, which is powered by the batteries, and is sent via Bluetooth to the Wi-Fi link on the PC, and transported to MATLAB, which graphs temperature and places the box of the heart rate. Our bill of materials, this project was really cheap at $114.80. Our most expensive thing was Bluetooth modem, which was $64.95. Not too expensive for Bluetooth, and this thing transits quite far. We experimented today; it went over the length of a football field, so it transits quite far. And for software, I'm going to go to Connor Blush.
All right, I'm Connor Blush. We're talking about software today. We use two main software codes with Windows as our operating system. First, we use the Arduino code for Teensy. This is the simplest one. It's very similar to C, and it allowed us to calculate heart rate, and it allowed us to formulate data transmission with the Bluetooth. The Windows operating system was the easiest one to talk between the Teensy and the MATLAB, and it's also most readily available. The MATLAB was on the laptop, and it converted the voltage data into temperature, and it also graphed the data as well. And it displays the heart rate sensor, or what the heart rate sensor would pick up in a colored text box, and it'll change depending on what the temperature will tell you. And it saves it in a .text file from MATLAB. Alright, this is a quick flowchart on how the Teensy works. First, you're going to initialize the temperature sensor and the optical sensors. It's going to read through, and it's going to ask, is the body temperature at a critical temperature? If not, it's going to keep reading the next file until we eventually get that it is reading at a critical temperature. It's going to turn on the Bluetooth transmitter, and then it's going to follow up with transmitting the heart rate and the temperature to MATLAB. Now, this is what is going to come from MATLAB. We're going to get that user info from the Teensy board, and it's going to display the data on that graph and that heart rate text box. It's going to ask, is that body temperature critical value? And if not, it's going to keep displaying real-time data. If it does, it's going to turn on the indicator for heat exhaustion, as I'll show you on the next slide. Here you're going to see two representations of what you're going to see in MATLAB. Here you're going to have temperature, and then the heart rate box, which is going to display the heart rate in beats per minute. On the top one, you're going to see we have a threshold on this one at 100 beats per minute. So if it's above 100 beats per minute, you're going to see a red box. And here, you'll see that the threshold is below degrees. Sorry, my mistake. You're going to see 100 degrees, not beats per minute, and it's going to be 100 degrees, and you see it's below, it'll be a yellow box.
Alright, my name is Sean Kettner, and I'm going to tell you what actually happened. I'm going to put on a plan and tell you what actually happened. The good words of Mike Tyson, everyone has to play until you get hit. Alright, so, what went wrong? For our sensors, we had a lot of problems with accuracy. There's a lot of noise, and we had to use Shilly cable, and it was just a really hard problem. We didn't put a lot of time into it in the beginning, and it wasn't until the end that we were like, gee, our sensors weren't really that good. Alright, for the next one, to use Shilly cable or to not use Shilly cable. Obviously, our device was a Garmin, so we wanted to use conductive thread and sew it with the conductive thread to connect the Teensy to the sensors through the actual Garmin. But the problem was we had a lot of noise, so we can't get into the discussion of do we just sew the shielded wire onto the Garmin, or do we still try to go with conductive thread? In the end, we went with Shilly cable. We got the best sensors, the best data from the sensor possible. So I think we made the best decision that we could possibly there. And for a third problem was use an OEM Arduino board, which is Teensy. So it was made by a guy in his basement, pretty much. But so we're not exactly sure if the Arduino coding varied a little bit from the code that we found online to use our sensors, but we believe that you had to do a little bit of on-the-side work to get our code from the Teensy board to work as we wanted to. So, what went right? For our software, as far as MATLAB goes, we were very happy with it. We did a lot. Our MATLAB software worked pretty well. We were able to plot, show an indicator, and show beats per minute. And we could run this over and over again for the span of how the laptop turning off if the battery died, or the Teensy battery dying. We had a lot of help from the electrical engineering department, from Dr. Skinner, Dr. Potasud, and Mr. Knapp, which we appreciate. And saving the data and transmitting the data was really easy. Like, it was barely one line of code, and we would just save all our data to a .text file. So if you ever wanted to look at the temperatures and heart rate of that you had during a sporting event, you could just bring it up. All you gotta do is double click. Alright, so the connectivity between the Bluetooth transmitter and MATLAB was also really good. There's actually a tool, the instrument control tool that we found on MATLAB, which pretty much gives you the code to connect from a Bluetooth device to MATLAB, which made it very easy. And our connection between the laptop and Bluetooth were excellent, and we had no problem with that. Our interaction with the HES department was also really good. We were able to take our ECG sensors, which we were using at first, over to the HES department and hook it up to their devices and get better results and find out that really ECG was not the way to go. And our Team 2 board had a very easy power budget. All we had to do was pretty much connect the battery to one pin and connect the other one to ground, and it was ready to go. The Team 2 board powered all the other sensors and the Bluetooth transmitter. Because power budget was something we were worried about, and it actually turned out to probably be the easiest thing in the entire project. So what we learned, sensitivity and accuracy of sensors is not that good, especially when you're trying to use open source. Our open source sensors were just not that good. They only cost us like $5 to $10. So in the future, we know if you're using a sensor and you need to get a really accurate result, make sure that you spend the money on the important parts. Bluetooth was the best way of transmitting. At first, we thought about it going ad hoc, but that would have taken a lot of extra programming. Bluetooth, all you had to do Bluetooth worked really well with Windows and MATLAB. So if we would have just stuck with Bluetooth from the beginning, that would have taken a lot of time out of the equation. So Bluetooth is a very good idea, especially for under 100 meters of communication. And once again, there is a lot of noise in the world and things that can mess up your sensors. So that's one of the things you've always got to keep in mind. So where does the Bro go from here? If we were to follow up on this project and try to market it, we would first put a lot more effort into new technologies for our sensors. I know we tried to get some proprietary knowledge out of some heart rate monitor experts. We obviously didn't get it because we're not just going to give away their technology. But maybe we could partner with another company or something like that because we're very confident with our software. It's just our sensors. And also for software, it's very functional, but we'd like to move it over to LabVIEW because LabVIEW is a lot easier for, say, an athletic trainer or an everyday Joe to be able to understand and view. So we would definitely want to move over to LabVIEW if you would consider. So let me wrap this all up for you. What do we need the Bro for? Because in the world, we got people that go way too hard. If it's in sports and it's in the real world, in the military, they don't want to stop and take a break. They want to keep going until they get the job done. And there's not enough people to protect these. If there's not enough people to actually see if these people are actually suffering from an injury. There's only so many athletic trainers on the field at a time. There's only so much you can pay for. And the Bro is an answer to that. So you can have one person who can monitor multiple people at the same time. And these injuries are preventable. And the Bro is the best way to prevent these injuries. And once again, what makes up the Bro? We got a thermistor temperature sensor, an optical heart rate sensor, Teensy board, or Teensy board 3.0, the Bluetooth transmitter, a laptop, MATLAB, and once you put all the components of a Bro together, put them on a garment, you're ready to go. We'd like to thank Dr. Skinner real quickly, who was our advisor. He was always there for our good questions, our not so good questions, and he always kept our morale high. And we also had Dr. Pasuk, who gave us a lot of good ideas as far as MATLAB goes. Dr. Peoples, who was our leader, who brought us in every day and made sure we were doing the right thing and we were getting the job done. Mr. Knapp, who was down in the trenches with us, soldering and making sure we were doing the right things and helping us out getting all that noise we got from our sensors. And also, we'd like to thank the HES department and Dr. Garner, who let us use their facilities to help us gain understanding of health-related sports, about sports, and and whatnot. All right, any questions?
Budget, you talked about your hardware budget, what about all these expensive software tools? What's a MATLAB license cost, and what's it cost to upgrade to a Logic license?
Obviously, sir, it does cost a lot to get a MATLAB license, and that would be something where the customer that we would sell it to would have to obviously buy a license to it would be the main cost. But the idea is once they bought that license, they have it, and if we kept the present hardware down, they'd still buy into it.
Now, is there a relative difference to upgrading to LabVIEW as opposed to MATLAB? Would you consider that and recommending changing?
We didn't really look at pricing for either of those, but as far as functionality and user friendliness, that was what was behind that thought.
Were the temperature sensors and the heart sensors in the same spot, or were they?
Okay, that's a good question. The temperature sensor, we decided to put that underneath the armpit, which is one of the places which is closest to your actual body temperature, because your skin temperature is obviously at a different rate than your body temperature. We were able to put it underneath the armpit and get that around 1 or 2 degrees of what your actual body temperature would be, and then we could adjust that number using MATLAB so that we could actually get a good body temperature. The heart rate, the optical sensor, we put that on the ear because that was it had to be on a capillary, so that would either be your finger, your ear, your lip, your nose. So the ear we decided was the best place to put it, so that you could actually play sports.
If we were gonna like